Here we have a bird's eye view of two cars. We're looking down on the Earth as these two cars are traveling towards each other. Car A, with a mass of 1,340 kilograms, travels east at 21.3 meters per second. Car B, with a mass of 2,150 kilograms, travels north at 18.4 meters per second. The vehicles collide and couple. Find the resultant velocity of the coupled vehicles. Somebody runs a stop sign here, and these two cars smash into each other, and when they slide off as a couple, clearly they're going to slide off up and to the right. With what velocity do they initially begin sliding in that direction? Well, to solve this problem, we are going to have to conserve momentum in two dimensions. And here's how we tackle that. For a system, the total momentum is conserved, and so are components of momentum. If you take a look at car A, do you see that it has some easterly momentum, but no northerly momentum? Car B, on the other hand, has entirely northerly momentum, but no easterly momentum. It's those components that we're going to need here. Momentum is conserved, components of momentum are conserved, say in the x direction and in the y direction. Let's do the math. Let's first take care of the x momentum. If we look at this picture, in the x direction, which turns out to be east and west, the only thing before the collision that has x momentum is car A. Car B has 0 x momentum. At the end, these two cars are coupled together, which means they're stuck as a group, and they will have then a combined mass. In other words, 1,340 kilograms plus 2,150 kilograms. That adds up to 3,490 kilograms. And that combined mass will be scooting to the right with some x velocity, which I'm going to call Vxf. According to the law of conservation of momentum, those two sides should be equal. Divide both sides by 3,490, and we get the x component of the velocity to be 8.18 meters per second. Now we're going to do the same thing with the y component of momentum. Hopefully you can see that initially only car B has y momentum. Mass of car B times velocity of car B. At the end, these two masses are stuck together, and they are scooting in the upward direction with some final y velocity. And the initial y momentum should equal the final y momentum. We can solve for Vyf to be 11.34. What this means is that after the collision, the coupled mass is scooting to the right at a rate of 8.18 meters per second, or to the east, and this combined mass is also scooting up, or north, at 11.34 meters per second. So to find the resultant velocity, in other words the initial velocity right as these two collide, we simply have to find the resultant, and we know how to do that. Use the Pythagorean theorem and the inverse tangent function, 14.0 meters per second at 54.2 degrees north of east.